Okay, so this video is on a trig function. The first function we're going to look at is the cosine function. So before that, we go back to the unit circle. Remember the unit circle, it shows us our angles, yeah? So we go around here and we start at 0 degrees, 30 degrees, 60 degrees, 90, 120, 150, 180 as we go around. Yes, 210, 240, 270, 300, 330 and back to 360. So remember the cosine was our x-axis. So here, look at the blue arrow. As I move around, the blue arrow gets smaller and smaller. Up on 90 degrees, the blue arrow is gone, so it is 0. Now the blue arrow goes into the minus. When we're over at 180 degrees, the blue arrow is -1. Over here is -1, yeah. We go down, it gets smaller and smaller again. And now we're down at 270 degrees, and the blue arrow, the cosine is 0 again. You can always double check that in your calculator. Cosine of 270 is 0. And we keep going, it gets longer again, and now we are back to 360 or 0. So let me go back to 0. So now our cosine function, down here on the bottom, you can see it records all of that. So we start here at 0. Now, and at 0, cosine is 1. Our cosine function can only be between 1 and -1. So if we start at 0 and it gets smaller and smaller, if you look at the red dot is coming down. So now here we are at 90 degrees. And if you look at the function, the cosine is 0. And that's what it is. The cosine, the blue arrow is gone. Here the cosine is 0. So now we keep going and we're going into the negative. And here we are at 180 degrees and we are at -1. And then we go to 270 degrees and we are back at cosine is 0. And now we go at 360 and we're back to 1. So this is one period. We go, if you look at if you look at the function, this would be 1 revolution, 1 period. So yeah, so we go from hill into valley into hill. Yeah, so that's the cosine function. But then obviously we don't have to stop there. We can do another revolution. We can keep going. Yeah, each revolution is what we call 1 period. And we can also actually do clockwise revolutions, and then we would go into the negative. Yeah, so that would be possible as well. So the cosine function is essentially a wave function. It has a period, it has an altitude, and so it has a period and has an altitude, it has a range. So we will talk about that later. But the range of our basic cosine function is from 1 to -1. It can't go anywhere else. And this is because of the unit circle. So let's look at the sine function now. So the sine function looks slightly different. Remember the sine function, again, it is a wave function. The sine function now is our y value. So look at the green here, yeah? So if we start at 0 degrees, the y value is 0. Yeah, there's no green arrow. So that's why we start at 0. Our sine function, 0 degrees is 0. If you put it in the calculator, the sine of 0 is 0. Now we go to 90 degrees. So we're going up. So this is now the sine of 90 degrees is 1. So that would be our highest point, and then we're coming down again. Here at 180, the y value is 0, our sine is 0. and now we go into the the minus one at 270, and then we go back to 360, 0 or 360, and we are back at sine is 0. Yeah, so the sine function is very similar to the cosine function, but it is shifted. Yeah, so it is shifted by 90 degrees. We start at 0. We also have a tan function. So the tan function looks like this. Remember, tan is a sine over cosine. Yeah, so but you can never divide by 0. Yeah, so if you put something in your calculator, 5 divided by 0, it'll come as up as an arrow. You cannot divide by 0. So we have, so our tan, so if I come to the point where sine is, where cosine is 0. I have to get to the point, so it's sine over cosine. You cannot divide by 0. When I get to the point where cosine is 0, the function is not defined. It'll actually go up to an asymptote. Would be our asymptote. So it'll never ever reach this point. Yeah. So for the values 90 degrees to 70 degrees, wherever the cosine is 0, the function is not defined, and that's why we end up with this row of functions. Yeah, so it's a row of waves like this, and we keep, yeah, but it's not continuous. Yeah, so the tan function is not continuous because we cannot divide by 0, and wherever the cosine is 0, these points don't exist. So this is what the tan function would look like. Okay, so let's go back to the cosine. Okay, so I just want to, once I write on it, I can't move it anymore. So let's just go back to here. Okay, good. So let's see now. So the cosine. Okay, so I just want to label it because hasn't been labeled. So we have 1 here, minus 1 here. So, and this is 0 degrees. And as we now can't move it anymore. So here, remember, cosine is 0 whenever we have 90 degrees. It is minus 1 whenever it is 180 degrees. And then it becomes 0 again at 270. And one period is finished when we are 360. And then the whole thing starts all over again. Yeah. So that would be then 360 plus 90 is 450, 540, 540, what is the next one? 630, and then we're up here again at 720 degrees. We can also write this in pi. Yeah, we can say this would be pi half. This is pi. This is 3 pi half. And 2 pi. And we can keep going with that. Yeah, so you can have that in degrees or radians. And it is a continuous wave. Yeah. And from that we can actually always read the cosine. Okay, so let's have a look at the sine now. Okay, so the sine, again, if I label it, it goes from 1 to minus 1, just like the unit circle. We have sine of 0 is 0. Then again, we have 90 degrees. The sine of 90 is 1. The sine of 180 is 0. The sine of 270 is minus 1, and then the sine of 360 is then again 0. And this would be one period here, yeah? So from here to here is what we call one period, and it keeps repeating with each revolution and also in the negative. One period is here. Okay, so that would, and again, we have a wave function. And then let's look at the tan and the lastly. 1 sec. So let's label the tan now. So the tan goes. 1 sec. The tan keeps going here like this, yeah. So it doesn't fit. It doesn't just go from 1 to -1. It is an infinite, yeah. It goes all the way up and all the way down. But as I said before, wherever, so remember, tan is sine over cosine. That gives us the cosine, and wherever the cosine is 0, because we cannot divide by 0, wherever the cosine of theta is 0, it is not defined, and the cosine is 0 at 90 degrees and 270 degrees and so on. So here we have our 90 degrees, our 270 degrees, and at that time it's not defined. It will never ever reach this point, yeah. So the graph will go close to it, but it will never get to this point, yeah. So the graph will come closer and closer and closer to this line, but it'll never cross it, and that would be your tan functions. Okay, so what I would like you to do now is read in your book chapter, 1 sec. Yeah, so read section 3.7. Let me move that up. Read section 3.7, and on page, it starts on page 124 in the green book, and then do the exercises. Let's say 1 to 6 on 1 to 6, page 127. Okay.